Hello students, in previous lectures we studied mean and median or the other positional averages. And now today we learn the mode of the distributions or data. So first we will discuss the mode. What is the mode? Mode, that means mode is the simple the observation which is repeated maximum number of time. The observation which is repeated maximum number of time, that is called mode. जो observation बार बार जो value बार बार repeat हो रही है, that is the mode of the distribution. So now for ungrouped data we will discuss Standard 11 statistics, chapter number 2, measures of central tendency. And the today's topic is mode. The observation which is repeated maximum number of time, that is called a mode. Now I will discuss for the ungrouped data. Ungrouped data and for grouped data. Okay. Now see the ungrouped data. For ungrouped data, that's very simple. That's called a raw data also. So the information collected is without arranging any form. It's a raw data. For example, a test is conducted of 20 students. A test of particular subject like accountancy. A test of accounts conducted for the 20 marks. And the marks obtained by the students is 5, 12, 18, 6, 5, 12, 15, 7, 15, 9, 10, 15, 6, 19, 7, 15, 4, 13, 8, 15. Now observing the data, ये data observe करेंगे तो पता चल रहा है कि the which observation is repeated how many times. So first the 5 is repeated 1 time, 2 times, and okay. The 12 is repeated 1 time, 2 times. That's okay. Now 18 is repeated only 1 time, 6 is repeated only 1 time, 15 is repeated 1, 2, 3, 4, 5 times. 19 is 1 time, 10 is 1 time, 9 is 1 time, 7 is 2 times, 4 is 1 time, 13 is 1 time. So the observation 15 is repeated 1, 2, 3, 4 and 5. So the 15 is repeated maximum number of time. So in raw data, that's a very simple. We can say MO is equal to 15. That is the answer. Only one sentence में ही answer है. The observation 50 is repeated maximum number of time. That's why the value of mode is equal to 15. So it's very simple. Now for discrete frequency distribution. Discrete frequency distribution we know very well. xi and fi. For discrete frequency distribution, the definition is very simple. The observation की जगह means the observation of frequency दोनों है. The frequency shows the number of repetition of the value of observation. So the for discrete frequency distribution, we can say the mode is equal to the observation having highest frequency. जिस frequency सबसे highest है, that means the observation is repeated maximum number of times. So again, the observation having highest frequency is known as discrete frequency distribution. Clear? So now we take the one example. Okay, 4, 5, 10, 19, 6, 3. So here, see the 0 is repeated how many times? 5 times. 1 is repeated how many times? 10 times. 2 is repeated 19 times. 3 is repeated 6 times, and 4 is repeated 3 times. The frequency fi shows the number of repetition of observation. Observation कितनी बार repeat हो रहा है? So the observation 2 is repeated 19 times and it's a maximum number of times. That's why the which observation is repeated maximum number of times? 2. The observation 2 is repeated how many times? 19 times. तो कई बार मिस्टेक हो जाती है कि m is equal to 19. That is the wrong. 19 it shows the number of time, but the observation 2 is repeated 19 times. That's why mo is equal to 2. That is the answer. That's very simple. लूप डेटा और डिस्क्रीट फ्रीक्वेंसी में ये आंसर बहुत ही सिंपल है. इसलिए ज़्यादा एग्जाम यानी कि मैंने मीन्स यहाँ पे नहीं दिए हुए एग्जाम्पल्स. बट अब नाउ फॉर कंटिन्यूअस फ्रीक्वेंसी डिस्ट्रीब्यूशन we will discuss in detail continuous frequency distribution. Now the continuous frequency distribution, the mode for continuous frequency distribution. Continuous frequency distribution. So in continuous frequency distribution, the first step, first find the model class. First find the mode or model class. Mode class. सबसे पहले तुम्हें mode class find करना है. And we know very well the mode class. So the mode class is the class having highest frequency. The class having highest frequency is known as mode class. The class having highest frequency, the same as discrete frequency, the observation having highest frequency, the same with the class having highest frequency. It means this class की frequency सबसे highest हो. Checking in the frequency, it means fi column. The highest frequency shows the model class. The respective class is the model class. The frequency, the highest frequencies or the respective class of highest frequencies for the model class. So model class decides होने के बाद to find the value of mode. Find the value of mode. Mode की value find करनी है तो that's formula mo is equal to L plus fm minus f1 divided by 2fm minus f1 minus f2. Maybe in 10th you learn that's 0 and 1 ऐसे भी तुमने किया है. But f1 f2 that's as per the book I recorded. We know very well that's into c. That's a continuous frequency. That's why into c. Now L is equal to, we know very well L is equal to lower boundary point of model class. Point of model class. So lower boundary point of model class. Now fm is equal to f, that means frequency, m means model. The frequency of model class. f1 is equal to frequency preceding the model class frequency preceding, that means previous to model class, and F2 is equal to frequency succeeding, that means next to model class. And C is equal to class length of model class. So write down properly the formula. Then wait for the example. Now here is the example, the output of the item and the number of workers. So first we find the model class and then we find the value of mode. What is the model class? So in continuous frequency, the class having highest frequency, so here the frequency is 4, frequency 5, 19, 33, 48, 22, 12 and 6. The highest frequency is 48. That's why 190 to 200 it becomes our model class. So first step, the model class or mode class is equal to 190 to 200. Clear? 190 to 200, that is our mode class or model class. Now we find the value of mode by applying the formula M0 is equal to L plus Fm minus F1 divided by 2Fm minus F1 minus F2 into C. So L is equal to lower boundary point. L is equal to lower boundary point of the model class. So lower boundary point is 190. Again, the class is inclusive or exclusive. Check the class or inclusive or exclusive. If the class is exclusive, then lower limit is the lower boundary point, and here the class is exclusive. That's why no need to find the boundary point. Now L is equal to lower boundary point 190 plus Fm is equal to frequency of model class. It is the Fm. It's a preceding F1, succeeding F2, and the class length of model class. So Fm is equal to frequency of model class. The frequency of model class is 48 minus the frequency preceding to model class is 33 divided by 2Fm minus F1 is equal to frequency preceding the model class 33 and minus frequency succeeding the model class is 22 and into the class length of model class is 10. Now 190 plus 48 minus 33. 48 minus 33, that's 15 divided by 48 into 2, 96 minus 55 into 10. Now 190 plus 15 divided by 41 into 10. So 150 into 10 is equal to 190 plus 150 divided by 41. So 190 to 150 divided by 4. So 150 divided by 3.6585. 3.6585. So now 193.6585 is equal to 193.66. That is the value of mode. The mode lies between 190 to 200. So the answer is 193.63. So that's a very simple. और एक चीज है वो भी डिस्कस कर लेते हैं कि मीन्स व्हेन द